For the beams loaded as shown by area moment method, determine the slope and deflection at the free end of each of the loading shown. EI is constant. So take note that we solved this in example 100C by double integration method. This time, let's solve this problem by the area moment method. So for the first situation, this is the beam and the moment diagram by parts. So we have the tangent at B, tangent at A, and that's the angle theta. And supposedly this is the deviation of point A relative to the tangent at B, which is horizontal. So deviation of A relative to the tangent at B is automatic the deflection at A also. So this is the moment diagram by parts. This is negative. The horizontal line is here. So therefore, for theta AB, it is area between A and B. So theta AB is equal to length times, this is negative M over EI. So therefore, it is negative ML over EI. Theta, therefore, the negative sign means that the tangent at A, which is inclined upward to the tangent at B, is clockwise. The rotation is clockwise. Clockwise rotation is negative, but the slope at the free end is positive because it is inclined up to the right. Therefore, in general, theta is ML over EI. Then for deviation of A relative to the tangent at B, which is automatic delta, it is equal to the area L times negative M over EI times moment arm with respect to A, L over 2. So therefore, delta is negative ML square over 2EI. Then for the second situation, the moment diagram by part is a triangle with the magnitude at B negative PL. So that's still theta, negative PL over EI. So the centroid is, the location of the centroid from the free end A is 2/3 of L. So for the area, theta AB is equal to the area of this moment diagram by parts, which is triangle, 1/2 of L times negative PL over EI, or negative PL square over 2EI. The negative sign means that the tangent at A to the tangent at B is clockwise. The rotation is clockwise, and clockwise rotation is negative. That's why this is negative. But the slope at A is positive. Therefore, theta is equal to PL square over 2EI. Then for deviation of A relative to the tangent at B, because the reference tangent at B is horizontal, that deviation is automatic delta. So it is 1/2 of L times negative PL over EI, the moment arm of the centroid of area from the free end, which is A, is 2/3 of L. Cancel out 2, so delta is equal to negative PL square over 3EI. PL cube over 3EI rather. Then for the third situation, the moment here at the wall, the degree of the moment diagram by parts is second degree. This is 0 degree plus 2. So it is a spandrel of parabola with value W times L over 2, or WL square over 2EI. That's negative. The location of the centroid from the vertical leg is L over 4, L over N plus 2, L over 2 plus 2, so L over 4. So therefore, the distance of the centroid from point A is 3/4 of L. So for the area, 1 over N plus 1, or 1/3 of L times negative WL square over 2EI. And that is theta AB. 1/3 of L times negative WL square over 2EI. And that is negative WL cube over 6EI. but the slope at the free end A is positive. The negative sign indicates that the tangent at A to the tangent at B rotate clockwise, so that's why negative sign, but the slope at the free end A is positive, so it is WL cube over 6EI. Now for the deviation of A relative to the tangent at B, that's the moment of area with respect to A. So it is equal to 1/3 of L times negative WL square over 2EI times moment arm, which is 3/4 of L. So cancelling out 3, so it is negative, delta is negative WL to the 4th over 8EI. Then for the fourth case, so the moment at the wall is 1/2 of L times W times L over 3. That would be negative WL square over 6EI. The location of the centroid from the vertical leg is in general L. This is 3rd degree. So therefore this is L over 3 plus 2, which is L over 5. So therefore the distance of the centroid from A is 4/5 of L. So theta is the area of the diagram. Theta AB is 1/4, 1 over n plus 1, 1 over 3 plus 1, so 1/4 L times negative WL square over 6EI. So that's negative WL cube over 24EI. But the slope at the free end is positive. It is WL cube over 24EI. WL cube over 24EI. While the deviation of A relative to the tangent at B is this area, same area times moment arm, which is 4/5 of L. So deviation of A relative to the tangent at B, which is delta, is 1/4 of L times negative WL square over 6EI times 4/5 of L. Cancelling out 4, so it is delta is negative WL to the 4th over 30EI. So for the general case, the degree of the loading is n minus 2, where n is the degree of the moment diagram due to this loading. So if the degree of the curve is, for example, 1, it is triangular, so that means, so n minus 2 is 1, so the degree of the moment diagram would be 3rd degree for that case. So we will call the moment at the walls, at this fixed end, as M wall. Then this is the degree of the moment diagram. This is M of the wall over EI, M at the wall over EI rather. So the location of the centroid from the vertical is L over n plus 2 in general. Therefore, when we have deviation of A relative to the tangent at B, so that's the moment of this area with respect to A. So therefore, the distance of the centroid from A is L minus L over n plus 2. And if we simplify, that's L times n plus 1 over n plus 2. NL plus 2L minus L all over n plus 2. So that is L times n plus 1 over n plus 2. So theta AB is the area, which is 1 over n plus 1 in general, times L times M wall over EI. Moment at the wall due to the loading is negative. So therefore, and the interpretation is negative because the tangent at A to the tangent at B rotate clockwise, and clockwise rotation is negative. But the slope at A is positive. So theta in general is, EI theta in general is moment at the wall, L over n plus 1. And please familiar with this formula because we can use this in superposition methods, especially for indeterminate beams. Then for the deviation of A relative to the tangent at B, it is the moment of area with respect to A. So negative MWL over N plus 1, that's the area, over EI. Then moment arm is L times N plus 1 over N plus 2. Canceling out N plus 1, so in general, EI delta is M moment to the wall L square over N plus 2 downward. So I do not put the negative sign, but its direction is downward. That's the general formula that I want you to familiar, especially when we apply this to superposition method.